I've got two new functions on the board, f of x and g of x here. And I'm going to do the following things. I'm going to find the domains of both f and g. Then I'm going to talk about the domain of f divided by g. And then I'm going to find a formula for that quotient function. And I'm purposely doing it in that order because I want to be thinking about the domain as I find and simplify the formula for the quotient. That's not to say that I couldn't find the formula first, but I think it will be easier for us to keep track of what's going on with the domain if we actually find that first. All right, so for the domain of f is a fraction, denominators can't be 0. So I know that x minus 3 cannot be 0. That means x cannot equal 3. If I graph that, that's everything except 3, and that shows me very nicely that in interval notation we've got two intervals. The interval of numbers to the left of 3, and then the interval of numbers to the right of 3. If you're comfortable going right to this, which would be the answer in interval notation, that's totally fine. If you want to show how you got there and graph along the way, that's totally fine too. All right, for the domain of g is also a fraction, so the denominator also can't be 0. This time the denominator involves an absolute value. So I've got the absolute value of x minus 2 cannot be 0. That means the absolute value of x cannot be 2. Remember to isolate the absolute value before we deal with it. And now I can say there are two numbers that have an absolute value of 2, and x can't be either one of them. So x cannot be plus or minus 2. Now, if I were to graph that, that's taking out two numbers from my domain, but keeping everything else. So that gives me three intervals. So I would get everything from negative infinity to negative 2, union negative 2, 2, union to infinity. Okay, so those are the domains of the two pieces that I have. All right, now if I want to combine these functions using division, okay, the same thing is true with division that's true for all the other arithmetic operations. In order to be able to do any arithmetic with f of x and g of x, both of them have to be defined. So the domain, everything in the domain has to be in the domain of both f and g. So I'm going to start with the intersection of these two domains. But when I'm dividing, I've got an extra restriction because g of x isn't 0, or can't be 0. So the domain of f over g is the intersection of the domains of f and g minus any x values, so I'm going to have to remove those, that make g of x 0. Oops, that make g of x equal to 0. So let's take a look. What would make g of x 0? Well, g of x is this fraction. Okay. So fractions are 0 if the top is 0 provided that the bottom isn't. Okay. So g of x equals 0 is going to mean that 5 minus x equals 0, and the absolute value of x minus 2 is not 0. Now this basically says that it's in the domain of g, so I've already figured out that that just means that x isn't 2 or negative 2. This is going to mean that x is equal to 5. So 5 is the only number that would make g equal to 0, so I'm going to have to remove that from the domain after I find I'm going to have to remove that from the intersection of the domains of f and g. So let me just draw my picture and line things up. Okay, so for g, we had removed 2 and negative 2, both of which are to the left of 3. So this was the domain of f, this was the domain of g. F over g, I'm going to first of all note that I've got to remove 5 because it would make g of x 0, and then I'm going to shade everything other than 5. Notice that 5 would be in the domain of any other arithmetic operation that I use to combine f and g. So it looks like everything's shaded twice except -2, 2, and 3, and then I've got to remove 5 as well. So this is a little crazy. My domain, we've got 1, 2, 3, 4, 5 intervals. So it's going to be -infinity to -2, union -2 to 2, union 2 to 3, union 3 to 5, union 5 to infinity. That is how we would write that in interval notation. Okay, so basically x is not allowed to be, I'm just going to write this in shorthand, x can't be -2, 2, 3, or 5. Okay, that's sort of my shorthand. Now I want to find a formula for f divided by g. Now, I know that that's just f of x divided by g of x. Now that's going to give me a complex fraction because f of x and g of x are both themselves fractions. So f was x plus 2 over x minus 3, and g was 5 minus x over the absolute value of x minus 2. Now notice, if I've written it this way, before I do any simplification, the domain is clear. I can see that x cannot be plus or minus 2 because that would make the denominator of this fraction that I have on the bottom equal to 0. I can see that x can't be 3 because that would make the denominator of this fraction 0. And I can see that x can't be 5 because that would make the denominator of the big fraction 0. I basically got 3 fractions here. The fraction on top, which is undefined if x is 3, the fraction on bottom, which is undefined if x is plus or minus 2, and then the fraction that's f over g, which is undefined if g is 0, which is if x is equal to 5. So there are 3 different denominators that I need to keep in mind. This denominator, and this denominator. Now, I'm going to go ahead and simplify this because generally if I'm dividing by fractions, I would flip and multiply. So I would say this is x plus 2 over x minus 3 times the absolute value of x minus 2 over 5 minus x. Okay. Now, I'm not done simplifying, but notice something interesting that happened. Now, I can still see that x can't be 3 because that's in the denominator. I can see a little bit more easily that x can't be 5 because that's in the denominator. But it's no longer obvious from the way I've written this that x can't be plus or minus 2. Because when I flipped in order to multiply by the reciprocal, the absolute value of x minus 2 got bumped out of the denominator. Now, usually when we're writing functions, it's understood that the domain of a function is the natural domain. The natural domain is just everything that you can plug in. If I stop here, I'm saying the domain is everything except 3 and 5, because those are the only things that I can't plug in here. But if I built this function by taking f and dividing by g, I need g to be defined, so x can't be plus or minus 2. So that's a restriction that I have on x that is not obvious from the form of the function that I have. When that's the case, it's necessary to write that restriction. Okay. Most restrictions are going to be obvious from the formula. But every once in a while, in simplifying things, when you simplify things, it's no longer obvious that you have a restriction on x. Something that used to be in the denominator got moved out of the denominator. Or maybe you had a square root that you squared, so it's no longer obvious that you can't have something negative because it's not under the root anymore. If that happens, it's necessary to write those restrictions, because I'm still trying to write a formula for f over g whose domain has 4 restrictions on it. So now the restriction that x isn't 3 and the restriction that x isn't 5 are going to be obvious from this formula. The fact that x can't be plus or minus 2, I have to explicitly state that. So that's something to be very careful of as you're simplifying. If your simplification makes it unclear that there's a restriction, generally the restrictions that we've seen are things in the denominator and roots. So if somehow in simplifying things you move things out of the denominator or you lift things out of a radical, check to see if you need to record some restrictions. Okay, I'm not quite done because of course I want to actually multiply this out. So I would FOIL both the top and the bottom. So on top, I distribute the x and get x, absolute value of x. Outsides would be minus 2x. Insides would be plus 2 absolute value of x. And last terms would be minus 4. And it looks like here there aren't actually any like terms that I can combine because absolute values of x and x's are different types of terms. Now on bottom I'll FOIL out. So let's see, I'll get 5x. Outsides give me a minus x squared. Insides give me a minus 15. And last terms give me a minus 3x. That I can combine the 5x and the minus 3x. So I can say the top is x absolute value of x minus 2x plus 2 absolute value of x minus 4 over, on bottom I'm just going to write in descending order. So negative x squared plus 2x minus 15, and I'm going to box that together with my restrictions that x is not plus or minus 2. That is now part of my answer because the domain of a function is part of the definition of the function. In most cases, the domain is clear from the formula, but sometimes when you simplify things, you need to explicitly record some restrictions that you have. All right, so what we just did is f over g. What I'd like you to do before the next video is find me the domain for g over f and find and simplify a formula for g over f. Doesn't matter what order you do things in, but just be careful as you're simplifying. If you have something in the denominator that you move out of the denominator, you will need to record that restriction as part of the definition of the function. The rest of the domain, if there's stuff that makes the bottom 0 and it's still in the denominator, you don't need to explicitly record that.